Hey, everyone! NASA has done it again. In September 2023, they brought home a piece of an asteroid, a sample from Bennu, a celestial body older than Earth itself. But when they opened the capsule, what they discovered left scientists stunned and the world buzzing with excitement. Buckle up, because today we're diving deep into what NASA found in the Bennu sample and why it could change our understanding of the universe forever. For the first time in history, NASA's OSIRIS-REx mission has achieved something extraordinary, collecting a pristine 4.5 billion-year-old sample from the surface of an asteroid. In May 2021, the spacecraft embarked on an epic journey, traveling 1.9 billion kilometers to bring this precious cargo dust and rocks from asteroid Bennu back to Earth. Fast forward to September 2023, after 2 years and 4 months in transit, the sample return capsule blazed through Earth's atmosphere at a staggering 44,000 kilometers per hour. This marked a historic milestone in space exploration, one that feels like science fiction come to life. Think of it, a time capsule from the dawn of our solar system, carrying ancient materials that could rewrite what we know about the origins of planets, water, and even life itself. Scientists are already uncovering incredible clues about Bennu's history. Could this asteroid have come from a once watery world? What new chapters of our solar system story will these tiny grains reveal? And there's more to the story. What happens next for the OSIRIS spacecraft? How will this groundbreaking mission shape future exploration? I'm Alex McColgan, and you're watching Astrum. Today, we'll relive the incredible return of the OSIRIS-REx sample capsule and dive into the amazing discoveries scientists have made so far. Plus, we'll explore the mission's next steps. Let's uncover the secrets of Bennu together. For the first time in history, NASA's OSIRIS-REx mission has achieved something extraordinary, collecting a pristine 4.5 billion-year-old sample from the surface of an asteroid. In May 2021, the spacecraft embarked on an epic journey, traveling 1.9 billion kilometers to bring this precious cargo dust and rocks from asteroid Bennu back to Earth. Fast forward to September 2023, after 2 years and 4 months in transit, the sample return capsule blazed through Earth's atmosphere at a staggering 44,000 kilometers per hour. This marked a historic milestone in space exploration, one that feels like science fiction come to life. Think of it, a time capsule from the dawn of our solar system, carrying ancient materials that could rewrite what we know about the origins of planets, water, and even life itself. Scientists are already uncovering incredible clues about Bennu's history. Could this asteroid have come from a once watery world? What new chapters of our solar system story will these tiny grains reveal? And there's more to the story. What happens next for the OSIRIS spacecraft? How will this groundbreaking mission shape future exploration? I'm Alex McColgan, and you're watching Astrum. Today, we'll relive the incredible return of the OSIRIS-REx sample capsule and dive into the amazing discoveries scientists have made so far. Plus, we'll explore the mission's next steps. Let's uncover the secrets of Bennu together. As the capsule hurtled toward Earth at an astonishing speed of 43,000 kilometers per hour, it claimed its place as the second fastest human-made object to ever re-enter Earth's atmosphere, just 3,000 kilometers per hour slower than NASA's Stardust return capsule. Along the way, it endured a jaw-dropping 32 G forces, or 32 times the pull of Earth's gravity. To put that into perspective, standing on Earth, you experience 1 G. Most people would black out at 4 to 5 Gs. Even today's astronauts typically face only about 3 Gs during launch, and fighter pilots, equipped with specialized suits, can only manage short bursts of 8 to 9 Gs. Now imagine surviving 32 Gs, an incredible feat, only possible because the return capsule was engineered to handle such extreme forces. As it streaked through the atmosphere, the scalding hot capsule reached temperatures of around 2700 C, half as hot as the surface of the sun. This fiery descent was so intense that infrared trackers on the ground were able to follow its progress through the sky. Inside the capsule, however, the precious 120-gram sample of asteroid Bennu remained perfectly preserved. How? Thanks to a state-of-the-art thermal protection system called I see a phenolic impregnated carbon ablator. This advanced heat shield worked by shedding over 99% of the capsule's kinetic energy, keeping the interior temperature below 75 C, a safe haven for the ancient sample. I see as brilliance lies in its ablative design, which uses a protective outer layer to safeguard the spacecraft. As the shield heats up, its outer material gradually burns away, carrying excess heat with it and ensuring the priceless cargo remains intact. This marvel of engineering allowed OSIRIS-REx's cargo to survive one of the most extreme journeys imaginable, bringing with it answers to some of the biggest questions about our solar system. During re-entry, the spacecraft faced intense friction as it barreled through Earth's atmosphere, generating enough heat to turn it into a fiery streak across the sky. To protect the precious asteroid sample, the capsule was equipped with a heat shield that used a process called ablation to survive the heat. As the shield heated up, its outer layer burned away, vaporizing and carrying the heat with it. This sacrificial shield absorbed the extreme temperatures, ensuring that the interior of the capsule and the Bennu sample inside stayed cool and safe. A couple of minutes after entering the atmosphere, the capsule had slowed enough to deploy its first parachute, stabilizing its descent. About 16 kilometers from the ground, radar systems locked onto its location, tracking it within just 10 meters of its target. As it neared the surface, a second parachute was deployed to slow the capsule further, bringing it down at a gentle speed of about 18 kilometers per hour, the pace of a skilled cyclist cruising on flat ground. From the moment it entered Earth's atmosphere to when it touched down in the rugged Utah desert, the entire descent took just 10 minutes. After years of meticulous planning, months of specialized training, and countless rehearsals, the NASA recovery team was ready. Helicopters quickly swooped in to secure the capsule, ensuring that the precious cargo was safely retrieved for study. To protect the precious Bennu sample, the return capsule stayed sealed until it was safely transported to a clean room and decontaminated. But when it came time to open the sample canister, things didn't go exactly as planned. Within just a few weeks, scientists at NASA's Johnson Space Center in Houston, Texas, were able to open the outer lid, revealing a surprising bonus: 70 grams of dark gray rocks and dust outside the main sample canister. While this extra material was valuable for scientific research, it wasn't as pristine as the contents locked inside the inner canister. The real challenge, though, was yet to come. Getting to that pristine sample took months of careful work, including the creation of an entirely new tool. Why the delay? Well, the mission was planned to the smallest detail, so why did they need a new tool just to open the canister? First, the unexpected bonus material slowed things down. All 70 grams had to be carefully removed, cataloged, and stored. This extra material actually weighed 10 grams more than the mission's original target sample. But that wasn't the only reason for the delay. Every step had to be done inside a nitrogen-purged glove box, an enclosed chamber flooded with nitrogen gas to prevent the sample from reacting with Earth's atmosphere. The painstaking process, combined with the need to handle the material with extreme care, made opening the canister a much longer and more complex task than anyone had anticipated. But all that effort was necessary to ensure the sample remained as pristine as possible for analysis. When you add the bonus rocks and dust to the original sample, the total amount of material brought back from Bennu ended up being more than double what the mission had initially aimed for. This treasure trove of space material was carefully cataloged and divided into smaller samples. In fact, at least 70% of it will be preserved in pristine condition for future generations to study, while the rest will be shared with over 200 scientists across the globe, giving them the chance to investigate pieces of asteroid Bennu. So, what makes this handful of space dirt so extraordinary? Imagine holding a piece of our solar system's ancient past, a sample packed with secrets about the origins of life and the early solar system. What incredible stories could an ancient relic like Bennu reveal? Just over a week after recovering the return capsule from OSIRIS-REx, scientists got their first look at the bonus sample called regolith. While Bennu may have broken off from a larger asteroid 1 or 2 billion years ago, its current chemistry and mineralogy were set in stone literally more than 4.5 billion years ago. Because its composition has remained largely unchanged over time, Bennu holds the primordial ingredients that existed before our planets even took shape. The sample from Bennu is like a time capsule, offering a glimpse into the very building blocks of our solar system. Inside the asteroid sample are what scientists call presolar grains, microscopic crystals that formed long before our sun existed. These ancient grains are like messengers from the past, giving us insight into the types of stars that populated the universe before our solar system came to life. Here's how it works. The mass of a star determines the elements it can fuse. Smaller and medium-sized stars primarily fuse light elements like hydrogen into helium, and later, heavier ones like carbon and nitrogen. In contrast, massive stars can fuse even heavier elements such as silicon and iron. When these giant stars reach the end of their lives, they often explode in spectacular supernovae, scattering elements heavier than iron across the cosmos. These stellar ingredients don't go to waste. Over time, they're recycled, forming new stars, asteroids, and planets. By studying presolar grains, scientists can trace the origins of these elements and piece together the cosmic story of how our solar system came to be. Pierre Hayanicourt, a cosmochemist at the University of Arizona and a member of the OSIRIS-REx team, shared an exciting discovery. Initial analysis of these presolar grains revealed evidence of both small and medium-sized stars, as well as supernova. This suggests our solar system was enriched by a diverse mix of stars long before it formed. Even more exciting, the first look at Bennu's sample showed it's rich in carbon and nitrogen, key ingredients for life. What other secrets might this ancient dust reveal about the origins of our solar system, and perhaps even life itself? The sample from Bennu contains organic compounds, essential building blocks of life as we know it. But that's not all. NASA's OSIRIS-REx science team also found evidence of water in Bennu's ancient history, thanks to water-bearing clay minerals in the sample. These findings confirm what scientists had previously detected in spectroscopic surveys of Bennu. As mentioned in an earlier video, this asteroid likely originated from a larger parent body that once harbored water. But how did these life-essential ingredients end up on a seemingly lifeless asteroid like Bennu? And why is there evidence of water and nitrogen, which are among the most abundant elements in the universe, forged within stars and spread across the cosmos? This abundance is awe-inspiring. As Carl Sagan famously said, "We are made of star stuff." Yet, while the building blocks of life are widespread, their presence doesn't necessarily mean life ever arose in these places. Bennu, for instance, is anything but hospitable. With no atmosphere and surface temperatures swinging from a freezing 73 C to a scorching 116 C, it's unlikely life ever took root there. Instead, Bennu serves as a cosmic time capsule, showing us how the essential ingredients for life, organic compounds, and amino acids are scattered. That water, a key ingredient for life, once played a major role in shaping the asteroid's chemistry. What other secrets might this ancient traveler reveal? The Bennu sample holds remarkable clues about the asteroid's watery past, suggesting it may have once been part of a much larger body that harbored water. Packed with minerals formed in the presence of water, the sample tells a dynamic story of transformation over billions of years. One of the standout discoveries was serpentine, a mineral strikingly similar to rocks found at mid-ocean ridges here on Earth. These ridges are where molten material from Earth's mantle meets water, creating new oceanic crust. Bennu's regolith also contained pyrrhotite, an iron sulfide mineral that can form near hydrothermal vents, hotspots on the ocean floor where heat and water interact to create unique chemical environments. Even more intriguing, the OSIRIS REx science team uncovered phosphates in Bennu's sample. These water-soluble compounds are vital for DNA and, in turn, for life as we know it. Their presence hints that Bennu may have originated from a much larger body, a water-soaked mud ball, or even a world with active geology and abundant organic compounds billions of years ago. While it's too early to conclude that Bennu's parent body was a full-fledged water world, Harold Connolly, a geologist at Rowan University and an OSIRIS REx mission scientist, shared an exciting insight. The evidence of warm water activity suggests that Bennu's parent body was at least 10 kilometers wide, possibly much larger. This discovery opens the door to thrilling questions. Could Bennu's ancient home have been a dynamic environment where life's building blocks came together? And how might this reshape our understanding of the early solar system? While scientists continue to delve deeper into Bennu's secrets, the findings so far have already expanded our knowledge of the cosmos. Let's rewind to 2016, when NASA's OSIRIS REx mission was launched with one goal: to visit Bennu and bring back a sample. This asteroid, about 500 meters wide, orbits the Sun and is believed to be a pristine remnant from the early solar system. After a 4-year journey, the spacecraft arrived at Bennu in 2020, collected its sample in a daring touch-and-go maneuver, and returned to Earth 3 years later. But why Bennu? Scientists believe it holds the secrets to the origins of life. And spoiler alert, what they found might just prove them right. Fast forward to September 2023. The capsule safely parachuted into the Utah desert and was rushed to NASA's Johnson Space Center. The moment of truth came when scientists opened it. Inside, they found something astonishing, far more material than they expected. Initially, the hope was to retrieve about 60 grams, but the capsule seemed to hold hundreds of grams. The sample wasn't just abundant, it was pristine, untouched by earthly contamination, making it an invaluable time capsule of the early solar system. Here's where it gets mind-blowing. Preliminary analysis revealed the presence of water locked within minerals, a clear sign that Bennu may have carried the building blocks for life. Even more exciting? Organic molecules, including amino acids, the very ingredients needed for life to form, were detected. These findings suggest that asteroids like Bennu may have delivered key compounds to Earth billions of years ago, kickstarting life as we know it. The Bennu sample isn't just a scientific treasure, it's a guidebook for the future. If asteroids can carry water and organics, could they help us sustain life on other planets? Imagine mining asteroids for water or resources during long-term space missions. Beyond that, studying Bennu also provides vital clues about asteroid trajectories and potential impacts on Earth. This mission isn't just about looking back, it's also about preparing for the future of space exploration. Bennu is like a cosmic time capsule, preserving information from over 4.5 billion years ago. By studying its sample, we get a glimpse into how planets formed and evolved. More importantly, it could answer the age-old question: are we alone in the universe? If Bennu holds the precursors of life, who's to say similar processes aren't happening elsewhere? NASA's findings remind us that the answers to our biggest questions might be hiding in the smallest fragments of the cosmos. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content. including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blesovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.